chưa.
Okay. Okay. Give me. I need to increase the volume. Yes. You can hear my voice?
Yes.
So just wait until most of you are here. 林成漢 are you here? 林成漢 did you see 當結起炸生理電入網加落一進推分入 Yes, okay. It's fine that we have got all of you here. Now, welcome all of you. Last night we come up with the topic on chapter 31, and I found some of you may feel a little bit worried now. So you are going to do this exercise very often. So we stop at 42 for a while for the remaining exercise. We have done most of them, right? So we'll post the answer to the web such that you can do it by yourself and have a recap. Okay, is that clear? So this is what we just stopped at it last time. Any questions so far? Before we come to the last two questions? Anything that is unclear to you when you think of the synthetic routes? The steps, the chemical reagents, the type of reactions, the products? If not, we would take a look on question 43 and 44, which is something about the qualitative analysis. Okay, qualitative analysis. So qualitative analysis. So định性分析. It is a chemical test for you to test for the nature of the chemical. It's quite different from that one in our organic chemistry. For organic chemistry, the qualitative analysis here only refers to the testing for the presence of functional group. So what is mean by that functional group? For example, it is just the reactive species, the reactive sites which will have the reactions. However, while you talk about LQ group or just CC single bond, CH single bond, all those, they are just very, very stable sites in which it will give you no obvious chemical property. So that's why we seldom get to know some chemical tests to identify how many carbons are there, or how many CC single bonds are there, etc. So remember, this qualitative analysis in organic chemistry, it will have its limitation. Its limitation is that it can only react with certain functional groups only. It's used for test for the presence of functional group. But whether or not they would, it doesn't tell you about the connectivity of the atom. No? What happened to it? It seems what happened to the connection again? Just wait for me. What happened to the connection? Again, the problem lies on the iPad again. So this one, yes, still yes. And yesterday I found some similar problem, but not the whole structure of organic compound. So I just know part of the structure, while the part of the structure refers to the presence of certain functional group. Presence. How about position? Not always will lead you know the position of a functional group, but some little clue can be given, but not a total, but not telling you the whole picture. Can you get my point? So it is rather problematic. So we will have a coverage of it again in Form 6. So that's why you would have the two chapters talking about it together. The first one is on this chapter 31, and then after these two, finishing these two questions, we go to chapter 52 as said last night. Okay, and we'll try to get to know more about the organic chemistry behind. So this is our flow of the lesson today. Any questions so far? Now take a look on question 43. Now, the two compounds X and Y is the isomers of the molecular formula C4H8O. The results of some reaction of X and Y that are listed below. So all those, they are just the chemical tests. Take a look on what is that. First of all, the reaction of PCl3, PCl5 to form steamy fumes are very special observation. So what is that? It tells you something.
Hydrogen chloride.
Yep, hydrogen chloride can be formed. So it's a very typical observation. I try to tell you some reactions has occurred. Second, both X and Y decolorize the aqueous bromine. And third, when reacted with chloride as certified KMnO4, both X and Y produce the same compound as this. Suggest which functional group is responsible for the reaction with phosphorus pentachloride and aqueous bromine. So anyone who can help? Yes. Anyone who can help about this? A very special observation, steamy fumes, right? HCl has been formed, so which means that certain chemical reaction have occurred. What is that? What is that? Do you know it? What is the functional group?
So hydroxy group.
Yes, hydroxy group. So you know the functional group being suggests that this functional group, the answer is hydroxy group. So what happened to it is that we have got a reaction. What is that reaction? Do you know? What is that reaction? It seems like hydroxy group react with PCl5 to form what? RCl, and together with the mist, HCl mist. So this is the mist. Why is it a white mist? Indeed, HCl is colorless. The gas itself is colorless. But once it meets the water vapor in air, I would say because HCl is highly soluble in water, so they will combine the two to form some misty fumes. So that's why we call it steamy fumes here. Is that clear? The more humid the environment is, or the more concentrated the HCl gas is, so you may find the more dense the steamy fumes they will form. Understand? How about number 2? Or aqueous bromine.
Double bond.
Carbon double bond. Agree? Carbon double bond. Yes, that's right. But indeed, if you want to make it as a functional group, right? If we call it carbon double bond. Unsaturation, right? You may write as an unsaturation, but functional group, okay, this is the one. And somebody may argue, Mr. Jim, would it have a case of CC triple bond? Quite rare. Why? It's not by DSC OC, it's by the formula. Take a look on that. Could you please talk a bit about it more? Because one of them is OH, right? So leaving behind, we've got 7H, and we treat OH as one group. OH as a group. OH as a group, and then we have got H as another group. We have got one group, 7 groups of atoms. We have got 4 carbon. Okay, so altogether, it gives a ratio of carbon to other atoms ratio N to N to N. Can you see that? N to N. So what is the hidden message? There is an unsaturation, while that unsaturation is what? CC double bond. Can you get my point? So the chemistry behind will be something like this. We have got CC double bond, a substance with a CC double bond, aqueous bromine. Very typical, right? Very typical. So what will happen to the structure? One is Br, the other one is?
OH.
Yes, OH, not OH2, it's OH. Now, remember, this one is a little bit different. While you talk about bromine water, or bromine solution, A equals bromine. Now, when you compare with bromine in organic solvent. For bromine in organic solvent, so what is the product? The product will be dibromo. So this is different. This is different, okay? So remember, a slight change in the solvent, which help dissolve bromine, it will cause different product. Any questions so far? Now, for those who love challenges, we have got Br and OH. In case the CC double bond is asymmetric, we still follow mechanical route to come out with a major product. Mechanical route. But Mr. Chin, it's quite strange, isn't it, right? Because you just talk about X, right? But for BROH, you can also have this phenomenon. While you would treat one of them is plus and one of them is minus. You better check it up by yourself on the web and let me know which one is plus, which one is minus. You know it? Is the thing, do you find it on the web and do you know which one is plus and which is minus? Now for the others, you might take a look on that. B part suggest structures for X and Y. Can you suggest the structure for X and Y? What can it be? First of all, we have CC double bond. We have got one hydroxy group. We have got 4 carbon, but they are both of them. They are isomers. They are not the same. Can you draw the possible structure of X and Y? Can you say which one is X, which one is Y? It's quite hard, right? Because as said before, the chemical test just tells you the presence of functional group, but they did not tell you the whole structure of the organic compounds. It's just by guessing. So we cannot say for sure which one is X, which one is Y. Just give me the possibilities. What can it be? Shall I hear some ideas from Wang Yulong? What can be X? What can be Y? What can be those structures? 4 carbon with CC double bond and hydroxy group. You may simply tell the structure by calling the name. What is that? Hello, when you're on, you here?
Yes, I'm here.
Yeah, tell me. What can be X and Y? If you take a look on A and B, it's quite different. But you take a look on these. Could you give you a hint? When reacted with gold, acidified chemical for both X and Y will produce the same product. Would it help? What can it be? So it will form a adjacent diol, right? But we have got 2 combinations, right? That hydroxy group can be the final product for that as a diol, but leaving another hydroxy group, the original species. Okay, the hydroxy group can come from 2 ways. One, the hydroxy group comes from itself. 2, the hydroxy group comes from the reaction between co-L acidified KMnO4 and the compound. Okay, you get my point? So they are either two way. I will hear Monica to say that 表2煙科，表2煙科 is it? 表2煙科。You nearly come up with the term. If you write down 表2煙科，I can guess what it is. 表2煙科 which is this. One, I would like to cross them out here. 1, 2, 3, 4. 表2煙 4. You mean this, right? However, for the numbering of this, you are going to make hydroxy the higher priority. So this one, this is 2, 1, 2, 3, 4. So the answer is, what is the answer?
表2煙溫爐。
Yes, it's 表2煙溫爐, is that? 表2煙溫爐. Now, for the naming, we got it 表2煙溫爐. So how about E? Do you still need to have a ENE or EN? Here, do we need to put a E here? Or you leave it as this? E no. No E. Agree? That because O and E both have both their vowels, so cannot come together. Second, 表3煙2. Is it 表3煙2? I see another suggestion as Wang Zhengyin, 表3煙2. Is it correct? 表3煙2.
應該表1煙2啊嘛。
表1煙2. 表1煙2. Is it? Now, so go back to this structure. What can it be? Now, you are going to think of the two combinations. The first combination comes from this and this. This is the newly formed hydroxy group. If that is the case, the structure of it will become what? 1, and then this, okay, and then this. This is the option 1. Option 2, if you are going to have this, these two, you come back together with the structure. So what is the product? The product will be now this one is OH. Can you get my point? So you are going to either hold one hydroxy group as the original substances and think of the other two as a diol and go back in reverse and think of the CC double bond, the position of it. So if you have got that two, how do I call it? The first one, which one is 表2煙溫爐? 表2煙溫爐 is this, right? This is 表2煙溫爐. How about this? How do I call it? 1, 2, 3, 4. So the answer is
表3煙2
yes, it's 表2煙2. 表3煙2. So this is the answer. Is that clear? So you are going to think it in either way. First, what are they in common is that the hydroxy group in the carbon 2 must be taken into consideration. Now you talk about this one. This is the carbon 2 in the product, right? So this must be the addition product to be formed, the hydroxy group, but not the original hydroxy group. You never have the combination of carbon 1 and carbon 3 to form diol. if you talk about CC double bond, react with cold acidified amino form. Okay, can you get my point? So you're going to either think of it as the hydroxy group as carbon 1 as an original OH, or the carbon 3 as an original OH. Is that clear? Finally, you'll take a look on the one of the compounds X or Y axis as a pair of cis trans isomers. Draw the structure of this pair for isomers. Which one? Which one would have got cis trans? You're showing, right? Yes, you are showing me the one in red, right? This is the first one. What is the second one? So you simply draw it like this. So this is trans isomers, and this is cis isomers. Is that clear? Any questions so far? Do you find it difficult? A little bit challenging, right? But once you figure out what is that the answer, once you write down the answer correctly, you can score marks. How about question 44? So for unlabeled, I hate that type of reaction, an assay type, right? Unlabeled reagent bottle each contains one of the colorless liquid listed below. So suggest chemical test to distinguish the 4 liquids. 2017, 5 years ago, right? Here comes this assay. So how many tests are needed for you to distinguish one from another? How many tests? Now, frankly, once you talk about this, you're going to think of it in sequence. You need to give me a series of tests which help you distinguish one by one. Okay, you get my point. So you may think of 2 patterns. One, suppose you have got 4 chemicals. We are going to do test 1, which will help further split it into 2 groups. 2 groups, okay? So because of different observation, and you are going to do the test 2, and then you are going to do the test 3 respectively. So suppose I have got that chemical, we call that ABCD, for example, ABCD, for example, after test 1, here comes AB here, and here comes CD here, and they do test 2, I further split it into AB, distinguishing based on the difference in the observation. That is method 1. Method 2 is by odd one out. So it is either by this ABCD, we have got the test like this, we've got 2 observations. So here comes A here to be found, and we have got B, C, D remain unsolved. So this is what you're going to do, and I do the same tricks. And then B, can you get my point? And C, C, D, and then C, and then D. So how many tests is needed? No matter which method you're going to choose, here comes 3 methods is enough. So your turn to tell me how you can distinguish, or no matter which method you're going to use, you are thinking of these 2 logic. 1 split into 2, 2 odd one out. Your turn to tell me what leaving behind is on the way to solve the problem. Or other chemical tests needed. To start with, chemical test, the first thing that you need to do is to what? Find the functional group. Now, hope it helps. Hope it helps. Now, add a few drops of bromine, dissolved organic solvent into those 4 solution respectively. I can hear Dungeon Hayes wording. So what will happen? If I use this as a start, as a very first test, which method are you adopting? The one on the left-hand side or the one on the right-hand side?
应该 right hand side。
Yes, it seems like right hand side. So we try to use this as a start. Okay, test 1. I write Dungeon Hay answers as the first. Bromine in what? Bromine in organic solvent. So you are going to add a few drops of. So what will happen to the two observations? Odd one out, right? Which one is odd one out? Which chemical? This one, right? Why? The chemical, this test is for unsaturation, right? So the one which has unsaturation will be odd one out. So it is CH2 double bond CHCOOH. So what is the observation? The orange solution is decolorized. Okay, it's decolorized. How about this on this flow? No observable change, no color change. The orange solution remains. So here comes BCD. So I continue on Dungeon Hay's work. Okay, so can you think of test 2? And you can walk on out here, right? This one solved. Remaining 3. Can you
a few drops of acidified potassium dichromate solution 得唔得㗎？
Oh, add a few drops of acidified potassium dichromate solution. So what is the expected observation?
有 hydroxy group 嗰個就會將 orange solution turns to green。
Yeah. So you may use this one. Yes, possible. So you may if you use the things one as the second one, you're going to add what? A few drops of acidified potassium dichromate solution plus warm the solution mixture, and you may have got the orange solution turns green. So you would have this, right? So one with hydroxy group. So what is that? It is propane 1,3-thiol. This is the one. Okay. So how about the other one? So it is no observable change. So you take a look on the third test. How we do this? Now I can see Dungeon Hayes suggested to use sodium hydrogen carbonate into it to test for COOH. Yes, that's right. You can either put it in test 2 or test 3. Both are okay. It depends on the logical flow. Can you get my point? So to the markers, we will have got so many various answers in mind. So whenever you draw it in a sequential manner with a logical sequence, if all those they are correct, I will give you marks. So if I adopt Dungeon Hayes case, if I have you put this into test 3, what will happen? Add a few drops. Is it a few drops? No need. Is it still few drops? Do we need to have a few drops for that? Or no need? Not necessary, isn't it? Not necessary. Why? Like this, right? So what will happen? First of all, already sodium hydrogen carbonate is okay. Cyrus, what do you think? Is it okay? So what is the expected observation? If you talk about
I think colorless gas will be given out, and I think this is insufficient because you need to pass the colorless gas into lime water and let it change from colors to milky, so that it can test the presence of the colorless gas to be carbon dioxide.
Yeah, okay, so you use lime water for further help to further identify the nature of the gas. So it will turn from colorless to milky. So you know that this one is carbon dioxide, while the chemical you are looking for is acid, CH3, CH2, COOH. This is propane acid. While leaving behind with no observable change, because there is no COOH functional group. This is an ester, CH3, COO, CH3. So it is ester. So no observable change while we react with sodium hydrocarbonate. So by doing so, you may have the flow. Of course, any question that you want to add, any point that you want to add. If I have got that flow, would they score full marks? One mark is missing. Do you know where? One mark is missing. It's on here. Why? What is that? What is missing? Physical state. Hey, wait a minute. Why would you say physical state? Yes, that's right. I need AQ. Why you will need AQ? But not just sodium. So you mean that if I add sodium hydrogen carbonate solid, is it possible? Is it okay? This one. No. Why not? Hint, go back to acid and alkalis. To the topic, acid and alkalis, and you can tell. Why? Why? Station.
We saw it.
For solid, no reactions. Why not? Why there's no reaction?
Because it hasn't ionized.
What ionize? I can hear the word ionize. There should some chemicals. There should be a chemical presence which will exhibit ionization. What is that? Solid and AQ. What is missing?
water 啊嘛，佢用 water dissociate 啊嘛。
Yes, that's right. Not it is water. So you will check your DSE past paper. You may have two steps, important step here. First of all, you add water, and then you add sodium hydrogen carbonate solid. Okay. This is okay. But if you don't do such action, just write down NaHCO3AQ, and it already covers, it carries the same meaning. Why? Because indeed for this chemical, these four chemicals, they are just pure without water. Okay, they are just pure. So including the acid, this one, the acid, here it is also pure, so no water is inside. So, but you may easily fall into a trap that it exhibits acidic property. No, sorry, no. Without water, the COOH will not ionize to form hydrogen ion. Okay, while hydrogen ion will then react with hydrogen carbonate to cause effervescence. Do you understand? Do you understand? So as said before, now for that steps, if you change the order of these three tests, of course, the A, B, C, D, the answer for that will be a little bit changed. Don't worry. They will also count your marks as long as you can really give the answer in the correct sequence and in a logical way. I will give you marks. Okay, you get my point? The similar principle applies to here. If I do this and I do all one now, what should be test one? What should be test one? The only test, the only choice. You can help you all one out. If I choose this one, I further split into two. You know? Yes, addition of sodium. Why? Why will you choose this?
Because two of them have the carboxyl group.
Yes,
no,
two of them has carboxyl group. So A and B must be with that COOH. So we have got AB here. So it will give you positive result. Effervescence. Okay, how about this? No observable change. So no carboxyl group. We've got CD here. So you do test 2 and test 3 respectively. So if that is the case, what is step 2? Test 2. It must be that. No other choice. Test 2. It must be that answer. What is that? Test for CC double bond, right? So you are going to add it, or the bromine, a few drops of bromine in organic solvent. So you are going to take a look on the orange to colorless. So you have got CH2, CHCOOH. But for this one, it is just CH3, CH2, COOH. That is no observable change. So leaving behind for test 3, here comes 2 without COOH, which is the first 2. You are going to test for redox property. So it is this one. You are going to test because this one is a primary alcohol. So you are going to add few drops of K2Cl2O7 acidified and plus warm. So you may have got the orange to green. No observable change as the other 2 cases, but for orange to green, it is with hydroxy group. But for this one, it is just an ester. Is that clear? Okay. Also, we have got 2 methods. So for the first method on the left-hand side, there's one definite answer. There's only one definite answer. How about on the method of the choice 2, you can swap the sequence of the 3 tests as long as you can opt one out for each. But of course, if you use the first step as sodium hydrogen carbonate, sorry, you have to go back to the method on the left-hand side. Okay, any questions? For those who you feel happy, who you understand what I mean, now could you please put a thumbs up into your chat box and let me know, right? To your name, next to your name, let me know if you really don't understand what I just said. If you totally don't understand, simply put a cross, let me know. How about the others? All gone. Yep. Yep. Okay. 黃俊熙、黃奕朗、陳俊熙、何慧琳、陳學嘉、陳許婷、李晴學校入馮家謙、張思維 ，those okay. You understand? 譚君佑、黃成軒、阿俊滔 ，you understand? If you understand, great. If you understand, that's fine. And we come to the chapter 52. Okay? Is it okay for you to go to what is meant by 60-40? What is mean by that? Oh, I see. Somebody said you don't understand. What you don't understand on which part? To what point do you don't understand? The flow? Or what? 點 present 啊? Oh yes, that is the flow. That is the flow. First of all, I will just give you a flow concept. To get to know the sequence. So once you are going to present your idea in paragraph length, you will have something like this. Point number 1. Firstly, add a few drops of bromine in organic solvent. For those chemicals in which it decolorized the orange bromine in organic solvent, it is CH2 double bond CHCOOH. While for the other 3, they have no observable change. For step 2, for the remaining 3 chemicals, add a few drops of acidified K2Cl27 plus warm respectively. For those chemicals, yes, I just read aloud as essay, but not writing essay. Indeed, this question, it is the past paper, while this past paper question, it is essay itself. So I just show you the way of thinking. Okay, I just show you the way of thinking. But once you know the flow, you are going to present it in paragraphs. Do you understand? So for point 2, yes. So for point 2, you are going to do the test on the remaining 3 chemicals. Remember, remaining 3 chemicals. Okay, so I've added a few drops of acidified K2Cl7 with warming. The one which turns orange solution turns green. That is the diol, right? While the other 2, they have no observable change. For the remaining 2 chemicals, you are going to add sodium hydrogen carbonate solution. Remember, that is the key point. Solution, aqueous solution. So the ones which cause effervescence, which later on be tested by lime water turning colorless lime water milky. It is CH3CH2COOH, while for the other with no observable change being ester. That's it. Understood? 跟唔到 Understood? All right. So it's fair enough. So go back to 52. Now, as said before, all those chemical tests, they are just used to test for the functional group only, but not telling you the true structure of this substance. As said before, for the other places in the organic compound, is quite stable, so it cannot be given any chemical test for you to do. But how can we know the true structure? Is by some other method. You know in Form 6. So today I would like to give you a further items on how to test for the 5 functional group. Now for ester, for amide, for amine, no need to know the functional group. Okay, so the chemical test. So what you focus on is just that 5 functional group. So that's for those students who are going to have a cheat sheets, a note card for you to memorize by yourself. Here comes appropriate time. you are going to draw something like this with the functional group. We've got a test with the positive result if there is the presence of it. Okay, so shall we start over that? Okay, first of all, carbon-carbon double bond. As said before, you will use a addition reaction using colored chemicals. Okay, it can be either bromine inorganic solvent or bromine in aqueous medium. So here comes different product. Can you see that? One is dibromo, the other one is hydroxy and then bromo. But for the color is different. For this one, you are going to add aqueous bromine. Check for the color. It is from right here as well, yellow or brown. Two colorless. This is also colorless, and this one it is orange. So make a very clear difference. Okay, remember in the DSE, the markers have already reported that the only method to distinguish them is to check the color, right? You are going to do not get exchanged, do not get confused of the two colors when you describe. When you write down aqueous bromine, that must be yellow or brown. If you write down organic bromine inorganic solvent, that must be orange. Is that clear? And second, no matter which one is it. So one more point that you need to draw attention is work quickly. Can you see that? Quickly. Also quickly. Both will say that quickly. How about not written? Now life is so unfair. In the question, it's just like this one. Can you see that? I write it like this without writing quickly. So you are just assume that it's quickly. Can you get my point? But once you are asked to write the answer, sorry, you have to write it down quickly. That's why I say that life is so unfair. Do you understand? So very unfair, right? Isn't it? And 52.3 is just that too. Of course, you may use Mr. Chin. Why don't they give you acidified potassium permanganate as the testing agent? Why isn't it appear? Why can't we? Yes, that's right. So remember right here, KMNO4, this one, even though I put in cold, dilute, blah, 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 blah. Yes, it can be tested for CC double bond, but once I get mixed with some other functional group, so it is rather problematic because hydroxy group also have reaction with this. So it is a matter of speed, but that reaction that may be rather confusing. So that's why we will not use acidified KMNO4 to have a testing agent. Even though I make it cold, very rare. Can you get my point? Very rare because that may cause certain type of confusion if there is a very simple alcohol. How do I say a simple alcohol? For example, methanol, ethanol. Recall your memory. If you have got ethanol last time in your lab section, once I get mixed with K2CO27 acidified, it has already turned the orange dichromic solution green without heating, without warming. Do you still remember? Could you please recall your memory? Right? So even though I put in hot room water bath, right, of room temperature, and I add a few drops of acidified K2CO27, and you will find that the redox has already occurred. That will give you a very important clue Never in reality, never use KMNO for acidified to test anything. Can you get my point? Because, well, whenever there is decolorization, that can mean a lot, right? It can be the presence of CC double, it can be the oxidation of alcohol, primary alcohol, secondary alcohol, aldehyde. Can you get my point? So very, very problematic. So you may see here K2SO7 as the choice. It can help react with primary and secondary alcohol. Tertiary alcohol not oxidized. Okay, but of course, if I do it in reverse, if I have something unknown chemical in which it does not turn orange dichromic green, can you say for sure that it is tertiary alcohol? Can you get my point? If you do a test, the logic, right? Write down the logic. So you are going to do the test on K2SO7 acidified. So the results, it is negative, which means orange solution remains. So what is the conclusion? So what is the conclusion? All of you, please mark it down. What is the conclusion? It's time I would like to test for the logic, right, of Chem 1 students. What is the conclusion? On the unknown. Of course, what is that? On unknown. Of course, I write that down, organic compound, unknown organic compound. And the results is negative, orange solution remains. So what is the conclusion? Are you here? Anyone who can help? What is the conclusion? Nope. Lâm Sài Gòn. Hello. I don't know thơ. Anyone who can help?
個 conclusion 係咪佢唔係primary or secondary alcohol 或者唔係咩 ketone aldehyde？
Yes, good. Okay, it is not a primary alcohol. The only answer is that there is not a only primary alcohol, not a secondary alcohol, and it is also not an aldehyde. So what can it be? It can be some others, except primary alcohol, except secondary alcohol, except aldehyde. Very strange, isn't it? So, but you cannot say it as it is it must be a tertiary alcohol. Can you get my point? So if you are going to but it comes to our concern, how can I find it as a primary, secondary, or tertiary alcohol? Very strange, right? The same logic. If I do the acidified dichromate solution on unknown organic compound, in case the result is positive, so what is the conclusion? It can be primary alcohol, it can be secondary alcohol, it can be aldehyde. Can you get my point? So it comes to our concern. How can we further narrow down the possibility to tell you it must be primary alcohol or secondary alcohol or aldehyde? Can you get my logic? That because those chemical tests are certain different functional groups, you will have a positive result. So it.
I think I may know.
Yeah.
You have add for step we have to add excess acidified potassium dichromate solution,
Excess.
excess in excess, until then you can differentiate if it is a secondary alcohol or not. So it is an odd one out.
Somebody would use excess on dichromic solution and check for the further color change, right? Anyone who agree or anyone who disagree?
應該再加埋 heat under reflux 啊嘛，係咪？
Heat under reflux. Somebody
Yeah,
will
heat under reflux.
now. What you just go back to the main primary question. What makes a good chemical test?
快嘅。
Yes, easily observable in a quick way. So as said before, heating under reflux is a technique which help you to produce certain type of organic compound, but it is not a proper way to be used as a chemical test because it's too slow. Okay, can you get my point? So that's why you need to know more tests. Don't stick back to the old method. And also for just go back, we get in response to Lei Ting's suggestions. The whether or not the oxidizing agent added is in excess or not really matters. Why? It's not because of the further reaction. It's because of the seemingly coming out of a false negative results. Take them up because that may be the orange color which will mask the overall color, and they will cause you a confusion whether or not there is a reaction. And there has been a reaction or a certain degree of the reaction. So this is not a proper way. So remember, whenever you have got a colored solution for testing, for the color change or decolorization, never, okay, never add it as excess. Instead, please use the term a few drops of. Remember. Either is for checking for the color change or decolorization. You still remember the term a few drops of. 真得千祈唔好 in excess. Now, I don't want to mention about KMNO4 because, as said before, so many different combinations. That's why here comes this. You are going to test for the aldehyde and ketones with functional groups. So they collectively share the same functional group. We call that carbonyl group. Carbonyl group. So carbonyl group, we need to test it with a chemical. We call that 2,4-dinitrophenolhydrazine. Phase change, what is that? 2,4-dinitrophenolhydrazine. Okay, 2,4-dinitrophenolhydrazine. So they will form somewhat insoluble in the mixture. We call that hydrazone. Can you see the word hydrazone? Hydrazone, which means these substances. Okay, we got a hydrazone. So the way to do it is very simple. And that reagents, we call that Brady's reagents, or you use that term. Remember to spell the word correctly. Or we use the word Brady's reagent, BRADS, Y''S reagents. So it tells you the same thing. So you are going to check for the orange or yellow or red PVD in case there is a carbonyl group formed. Bright red, orange, or yellow PVD. But that color doesn't tell whether or not it must be aldehyde or ketone. It's not a distinctive features to help you know the chemical nature of the substance. So no need, don't worry. Just tell me either one color and that's okay. And it is already tell you that it contains carbonyl group. Okay. So it simply get mixed with the solution of 2,4-dihydrophenolhydrazine to the carbon under test, and then in case it contains carbonyl group, it will give you a bright red or a bright orange or a bright yellow precipitate. Yesterday, you still, if you go back to the case, it seems that you are going to do if you use the acidified dichromic as a first test, if you got a positive result, here comes primary alcohol, the case, primary alcohol, secondary alcohol, and aldehyde, right? And I do the further test. It is a confirmatory test. You are going to use 2,4-dihydrophenolhydrazine to test for the PPT. Okay, so it will cause a what? It will cause if it cause a PPT form, it is aldehyde. Okay, it must be aldehyde, but not primary nor secondary alcohol. But if there's no PPT, you can still get rid of the case that it must not be an aldehyde. Can you get my point? So you can narrow down the choices to two only, primary and secondary alcohol. Is that clear? Mr. Chin, what you are talking about? But of course, if you can, if you do this as a first test, and it will give you a color PPT, you can do the second test, right? You can treat it as a second test to further tell it is an aldehyde or ketone. It is a very authentic example, or we call that silver mirror test. It is a silver mirror test. So it's by reacting with if what ammoniacal silver nitrate solution. What is that? How can it be made? With this complex. You're going to produce it in situ. It's by adding sodium hydroxide solution to the silver nitrate dropwise until some brown PPT is formed. So what is that brown PPT? Cyrus.
Ag2O.
Yes, Ag2O. And then not hydroxide. No such. Remember, no such. No such. There is no silver hydroxide in reality. And second, you are going to add silver oxide with excess ammonia in order to produce diamine silver 1 ions. While you use this, it is a very stable substance which will cause a redox to occur. Can you see that? It is a redox. It is from aldehyde to form carboxylic ion because you are now in the alkaline medium. So write down this one. And what's next is oxidized. It is oxidized, right? What is reduced? It is silver 1 ion. That will cause reduction. So silver 1 ion, here comes silver 0. So you are going to have a silver mirror that forms or inside of the reaction vessel. Now, for example, test tube, boring tube, and you have a very shiny, silvery inner layer. Now, while you do the test. Remember, while you do this test, remember to warm the mixture. So you see on the circle the word warm the mixture. So we call this agent a tolerance reagent. Tolerance reagent. Now you may directly write down tolerance reagent to get replaced with those steps above. But of course, in practical sense, you need to produce tolerance reagent by your own. Okay, because tolerance reagent is rather unstable when I place it for a long time. So that's why you're going to produce it in situ. So just like this, silver mirror, a redox. So this is what you may know about this. And how about hydroxy group? Remember, you are going to add aqueous solution of sodium hydrogen carbonate and liberate as carbon dioxide. You're going to test it using lime water to see if it turns milky. Okay. And also you may use ester formation to test for the carboxylic acid, but it will take a longer time. It will take longer time by reacting with alcohol. Okay, a type of unknown alcohol. I react with concentrated sulfuric acid, and I warm it a little bit, and I would pour the solution to the tank of water together with sodium carbonate solution. Once I pour this solution mixture, a layer of ester will float on top, and it is immersible in water. It floats on top and let you smell it. So let you smell it. So you may smell it as a pleasant fruity smell, but it takes a long time. Of course, you use sodium hydrocarbonate solution, and it seems easier. Can you get my point? So in short, today's experiment, in today's lesson, I just tell you this. But you still haven't solved, Mr. Chin. How can I distinguish between primary alcohol, secondary alcohol, and tertiary alcohol? You didn't give me any clues. You still haven't told me anything. So if you want to write it here, can you solve? Can you search on the web now? Sorry to say that I need to have, yes, I need to have 5 more minutes with you. Lucas test, yes, that's right. What is mean by Lucas reagent? How do I know that it is a primary or secondary or tertiary alcohol? I use Lucas test. Lucas reagent. What is said as Lucas reagent? Yes, Tan Junhei has got the answer. Now, could you please elaborate more? Lucas test. What is that?
The mixture of the zinc chloride and HCl.
Yes, zinc chloride and HCl. Corn HCl or dilute HCl?
Corn HCl.
Corn HCl. So what is the test result? Primary alcohol, secondary alcohol, and tertiary alcohol. So what is the result? Now, if you have got this link on the web, you may type it and share among the others, such that the others can take a look on that. Lucas test. For the others, for those who have searched it successfully, you may post it on the chat box. Lucas test. So first of all, what is the step? Lucas test. Lucas reagent. So what is that? So you are going to take a look on the chemistry about this Lucas test. So you are going to test for the turbidity, the cloudiness of the chemical reagents once I add zinc chloride with corn HCl. Why? Why do I have such a turbidity? It's because of the reaction. So what is the reaction actually? It is just the substitution reaction. Why? Because I said before, I have got hydroxy group and I would like to add corn HCl, which will help protonate the hydroxy group such that the hydroxy group can leave easily. And then you have got anhydrous zinc chloride. So the chloride ion will get substituted, okay, to substitute over the hydroxy group, and leaving behind is the coral. So which means that no matter is whatever it is, primary, secondary, and tertiary alcohol, they will form a coral, the coral compound, the halide. But why you say that cloudiness? Why we say that cloudiness? It's because of this low miscibility with water. Why I say that low miscibility with water? As said before, corn HCl, I use water to dissolve, right? To have it. So originally, the alcohol here can get mixed with HCl well. But all in a sudden, once I have formed coral group inside, it is immiscible. It's immiscible with other chemicals. Okay, it's immiscible. Why? No hydrogen bond with water, no hydrogen bond with the aqueous medium. Can you get my point? So it will form something that makes them well. We call that cloudy. So if I have got the tertiary alcohol, these substances will rapidly form. Okay, when you compare with primary alcohol, so the change in cloudiness is different. The time where you change it to cloudiness is different. Okay, so could you please mark it on here? Could you please capture a photo here? Please capture a photo here, and you write down 1, 2, 3. Captured. Now we go back to this. Could you please write down? Turns cloudy immediately, and then turns cloudy in minutes, and this one turns cloudy only by what?
Under heat.
Yep, turns cloudy upon heating, only upon heating. So which means that doesn't turn cloudy when no heating. But once I heat it, I warm it, and they will turn cloudy. So remember, it's time to change a little bit on the wordings to be used about Lucas reagent. So first of all, this one is in a hydrous form, and hydrogen chloride. You are going to have corn HCl. By doing so, you can produce the corn. You can have corn HCl to react with the hydroxy group, and because you are now making the aqueous medium highly ionic, so the coral group, the halide, will then, once it's rapidly formed, it will turn it as a cloudy to tell you there is the formation of those substances. As said before, tertiary alcohol is quite reactive, okay? It's more reactive to the attack of the corn HX when you compare with secondary, when you compare with primary. So that's why the substitution reaction is of different speed. And I make use of this different speed in the substitution reaction product being immiscible with water to tell you the difference between primary, secondary, and tertiary alcohol. Can you get my point? So maybe I just said quite a lot about today's work about the chemical test. So what you need to do is to capture this as well. Okay. And I would like to show you the video in these, especially 240 mph test, silver mirror test, Lucas reagent, tests. Okay, that free. We have got the videos with you. Okay, you better watch the videos to get to know more about how the reactions can be done. It is a preparation for you when we meet. Do you understand? So today, our lesson mainly covers 2 points. One, on the test, for the chemical test. Two, for the presentation of idea. Okay, for the presentation idea in terms of a logical flow. Okay, it can be the one on the left hand side. You divided the whole groups into 2, or you use the method on the right hand side, odd one out. Do you find things becomes more complicated than before? Somebody may say yes, because you are now having in an integrated manner. Okay. Now, before you go, could you please let me know your level of understanding from 0 to 10? I need to adjust the speed if you find it problematic. Just 5. Mm-hmm. 4. Just 4 for today. Yesterday you used to say the 8. All right. So for those others who want to watch the videos again, okay, you better refer refer it to the video. Okay, I will upload it shortly. Thank you. Bye bye.